Good everyone, my name is Graphics. Today we want to solve another problem in electrical engineering science, an aspect of applied physics where we are told to use Thevenin Theorem to find the current that is flowing through the 3 ohm resistor, right? So we know very well that a resistor is in form of a load in an electric circuit, right? So the resistor, the 3 ohm resistor, or the resistor that is having a resistance of 3 ohms is a load. All the resistors in this circuit is a load, but we are considering just the 3 ohm resistor, right? So we want to use the Thevenin theorem to know the amount of current that will be passing through that 3 ohm resistor. Now, first of all, we need to understand what Thevenin theorem is, right? And Thevenin theorem states that in any linear circuit containing several voltages and resistances can be replaced by just a single voltage in series with a single resistance across the load. What this is trying to just tell us is this, that no matter how complicated your diagram is or your circuit is, you must sum them up to give you a single voltage, a single resistance, that is a single resistance across a load, which will be having to be like this in this form, right? So we have the voltage here will be called the Thevenin voltage. That is, the single voltage will be called the Thevenin voltage. The single resistor or the resistance will be called the Thevenin resistance using arrow subscript TH. Then with the load that you are considering, which is given as what? Our resistor RL. So we're looking for this current IL that is moving in series, right? So if I want to write this in a formula, this will now give me that you know very well that according to Ohm's law, V is equals to what? IR, right? So we'll assume that we'll say that the V here is the Thevenin voltage, the I there is the load, the arrow there is the resistors in series. And look at the resistor in series here is our arrow Thevenin and the arrow load that which we are what we are considering. Now if I make my IL so to formula, I'll be having the load, the current that is passing through the load is equals to the Thevenin voltage over the Thevenin resistance plus the RL, right? Now this is what we're having here. So this is what we want to use to analyze that circuit, right? Now, if you look at the circuit closely, we have two voltage source, which is 10 volts and 5 volts. We have 5 resistors, which has resistance of 1, 2, 3, 5, and 4. Now, first thing we first of all do is to calculate for the Thevenin voltage. Now, for we calculate that, we need to remove the load or the resistor that has a resistance of 3 that we are considering. We're going to remove it and replace it with what? The VTH. And we'll be having this. You can see that? Now, we want to know the Thevenin voltage. The Thevenin voltage is the potential difference between these two terminals. Let's say terminal P and Q. That will be the Thevenin voltage, right? So now calculating for the VTH. Now I've removed it now. Now for me, there are two different ways that I can analyze this. I would like to go through the longer way, then I'll do the shorter one, depending on the one you will appreciate. Now let's see this. And you can leave your comment below and tell me the one you prefer. Now, if I name my mesh or my loop as I have A, B, C, D, E, F, G, and H, right? Now, I will consider loop A, B, G, and H. So let me draw that out, right? So I've drawn it out. If you notice it, this is what we are considering. Now I'm going to be applying the mesh analysis here, right? So we know that when current will start from here, from H to A, we're going in a clockwise manner, so we're moving in this manner. We'll name this mesh or this loop, we'll name it I1, right? So I name it I1. So I'm taking a clockwise direction, meaning that my current is flowing from this voltage source and it's flowing like this. You can see this is how the current is flowing. Now, since it's flowing in that direction, that means we'll be considering this movement. Now, so let's start. When current flows from a when we move from a lower potential to a higher potential, we'll be having a positive voltage, right? So we're having 10. Now, whenever current flows to resistor, we'll be having a voltage. Is that taken? So we'll say that the current that is flowing here is I1. When it flows through 1 ohm, it will be I1 times 1, so we'll be having I1. But since it is flowing through a resistor is a load, so it usually bring about voltage drop. So I'll input my what? My negative to show that what? It is flowing through the resistor in the direction of what? Of the current. Note that. Now, to the next one, through the 2 ohm resistor. So when I1 flow through 2, it will be the I1 times 2. That will be having 2I1. Since it is flowing through the resistor in the direction of the current, there's a voltage drop. So we have negative 2I1 equals to what? 0. Now, if I do the needful, collect like terms, it will be 10 minus 3I1 is equals to what? 0. So if I take my 3I1 minus 3I1 to the other side of the equal sign, it will become 10 is equals to 3I1. So if I make I1 the sort of the formula, I'll divide both sides by 3, right? So I1 becomes to what? 10 over 3, and that will give us 3.33 ampere. Now, if you look this closely, it means that the current flowing through BG, you can see this BG, this branch here, this BG, that is the current flowing through the resistor 2 is given as what? 3.3 ampere. Therefore, our V1, our voltage across the 2 ohm resistor, I call it V subscript 2, will now be equals to what? The current that is flowing through it times the resistance there, and that will be 3.33 times 2. So the voltage across the 2 ohm resistor becomes to what? 6.667 volts. That is for that. Now I will go to the other mesh or the other loop. I'm going to consider mesh or loop C, D, E, F. Let me draw it out. So when I draw it out, I'll be having this way, right? I've taken this section out. So we have the 5, 4, and we have the 5 volts here. So if I am going in an anti-clockwise manner, I just want to go through the direction through the positive side. So I'm starting from this positive and I'm flowing in this direction. You can see I'm flowing in this direction. So if current flows from a lower potential to higher potential, the voltage is what? The voltage is positive. So if I move from a lower to higher, I'll be having plus 5. Now, since I'm flowing through 5 ohm in the direction of the current, right, to be 5 times, I'm naming this my mesh I2, right? So it will be, it means that it's I2 that is flowing in this manner. So it will be 5 times what? Times I2, right? So that will give us minus 5I2 because when current flows through a resistor, there's a voltage drop in the direction of the what? The current. Now, the same thing, the current I2 flows through the 4 ohm resistor to be 4 times I2. That gives us negative 4 I2 because direction of the current. So equals to what? Equals to 0. Now, if I collect like terms, we're having 5 minus 9 I2 equals to 0. If I take my minus 9 I2 to the other side of the equal sign, to be 5 is equals to 9 I2. So dividing both sides by 9, my I2 will be equals to what? 5 over 9. So the I2 here will be equals to 0.556 ampere. Now what do you notice? The current flowing through CF, you see this point here, CF, right, flowing in this direction. That is current flowing through the resistor, the 4 ohm resistor is 0.556 ampere. So the voltage across the 4 ohm will now be equals to the current, which is I2, flowing through the 4 ohm multiplied by what? By the resistor, which is 4, right? So it will be 0.566, 0.556 times 4, and that will give us what? 0.224 volts. So it means that the voltage across CF, right, in this direction is given as what? 2.22 volts. Is that okay now? So that is what we have here now. So it has made our work easier, right? Now we've gotten the V2 and we've gotten what? V1, that means the V across the 2 ohm and the V across the 4 ohm. So this is where they are. Is that okay now? Now we can now calculate for the Thevenin voltage. So we're now going to consider the mesh or the loop BCFG, right? So considering the BEFG, we're moving, well, we now want to know the potential difference between these two terminals here, or I can easily say that my V Thevenin here now be equals to the the V 4 ohms, right? The voltage across the 4 ohm resistor minus the voltage across the 2 ohm resistor. Is that okay now? Because we notice it, they're in series. So when you do that, what you'll be having here is going to be the voltage across both of them here. If I press my calculator here, it will be 6.667 minus 2.22, and that will give us 4.45 volts. That will be the Thevenin voltage. So that is for that. So you can do it any of these two ways. Now I was saying something earlier. Another method you can use to get a VTH here just to save time, right? And if you can't remember on how to do your series parallel connection, you can click on this link at the top right corner of the screen here to show you ways at which you can analyze a circuit using your mesh analysis, right? So now let's see how it goes. I can use voltage divider rule to get my voltages here, right? Instead of going through mesh analysis, I can use the voltage to do that, right? So how will you do that? Now I want to know the voltage across the BG here. The voltage across what? The BG here. So since the voltage across the BG is the voltage across the 2 ohm resistor, using the voltage divider rule, it will now be the resistors that we are considering, which is the 2, all over the total resistance in that mesh. And what is the total resistance in that mesh? That is 1 plus 2, and that is 3. So 2 over 3 times the source, the voltage source in that mesh. And what the voltage source? The voltage source is what? Is 10. So if I use 2 over 3 times 10, I'm going to be having the voltage across the 2 ohm resistor to be equal to what? 6.67. Is that okay? You see how we get that so fast? Now if you now consider the other one too, if I want to know the voltage across the CF here, right, that is the voltage across the 4 ohm resistor, it will be the resistor that we're considering, which is 4, or the branch that we're considering, which is 4, all over the total resistance in that mesh CDEF, which is what? 4 plus 9, and that will give us what? 4 plus 5, that will give us 9, multiplied by the source in that mesh, which is given as what? 5 volts. So when you do that, you'll be having V2, and V across the form result will be what? 2.22. And when you subtract, you look for the difference, you're going to be having the 6.67 minus what? The 2.22, right? Or you say that the voltage across the 2 ohm minus the voltage across the 4 ohm, and that will be what? 4.45 volts. So that is how we go there. Now we move forward. We've gotten our VTH. Now the next thing we are going to be doing for is calculate for what? The ROTH, right? Now we want to calculate for the ROTH. Now for you to calculate for the ROTH, if you are having a voltage source, you are going to what? Short circuit it, right? So if I short circuit it, that means I'm going to remove the 10 ohms, the 10 volts and the 5 volt, and I replace the wire. So this is what I'm going to be having, right? And don't forget, you also remove your 3 ohm resistor that you're considering, and you write your ROTH instead of you put your VTH here. So you remove the VTH, you replace with ROTH, and you remove the voltage source. Is that okay now? Now when you do that, now you will now discover that at the left hand side, the mesh ABGHA, right? The resistor there in that mesh, they are in parallel, sorry, because different current is flowing through them, right? You're coming from this side. The current flowing through one is not the same current flowing through two. You can see the way it's moving this direction. One is going this direction, another one is coming this direction, right? So we say that what they're in parallel. So one is in parallel to two, plus, because this two is connected with what? With a wire, right? So plus, in the right hand side, if you consider the mesh CDEFC, you discover that the 5 and 4 are also in parallel because they're in two different branch, two different current is flowing through them in this manner, right? You can see the way it's flowing this way, it's flowing in this direction. So 5 is in parallel to what? To 4. So if I do that, my ROTH now will now be equals to, you multiply both of them at the top and you add both of them at the bottom. That means multiply both of them at the numerator and you add both of them at the denominator. So it will be 1 times 2 at the top divided by 1 plus 2 at the bottom, plus 5 times 4 at the top all over 5 plus 4 at the bottom. That is just the concept. Now when you do that, this will now give us 1 times 2 is 2 divided by 1 plus 2 is 3, plus 5 times 4 is 20 divided by 5 plus 4 is 9. So if you divide 2 over 3, you'll be having 0.67, plus if you divide 20 over by 9, you have 2.22. Now when you do the summation, this will now give us 2.889 ohm. So the Thevenin resistance in this circuit here is giving us 2.889 ohms. Now we've gotten the RTH, we've gotten the VTH. Now we'll now apply it in our formula above. So let's start. So from the formula above, we say that our IL, what is the L there? That is the load. Which load? The resistor. Which resistor? The resistor that we are considering, and which has a resistance of what? Of 3. So I'm going to write subscript 3 ohms here. Equals to, now the VTH we calculated to be what? 4.45, all divided by the ROTH we calculated just now, which is what? 2.889, right? Plus the ROL, which is the resistance that we're considering. We call it the resistance of what? Of the 3 ohms here. And our IL will now give us our I subscript 3 ohms, and the current through the 3 ohm resistor will now be 4.45 divided by 5.88. This will now be equals to 0.7567 ampere. So that is the current that is flowing through the 3 ohm resistor. So this is what we will calculate. So you can click on this link at the top right corner that will take you to a point that you can view more examples on Thevenin theorem. So if you have found this video helpful, please don't forget to click on the subscribe button. Thanks for watching.